So we have with us Rashmit Singh Sukhmani, CTO and Co-Founder from Satsure. I'll just give you a brief introduction about our speaker. He's a CTO and co-founder at Satsure, showcasing his adeptness in researching, collecting, analyzing, and effectively managing fundamental data on a large scale. He holds an MBA degree from Thomson Rivers University and boasts a diverse educational background encompassing both business and engineering disciplines, seamlessly blending technical and business expertise. We are fortunate to have with us Mr. Rashmit.
Thank you.
So
Thank
welcome
you
to this.
Yeah.
Over to you.
Thank you. Good morning, everyone. First of all, thank you for inviting me for a plenary session. When I gave this topic, I just wanted to showcase one aspect. Everybody would be talking about the tech, but how that tech converts into a value for the customer. This is what I want to show. And in terms of what value that it has created for Satsure in our journey from past 5 years, moving from doing things traditionally, moving towards AI ML to scale the solution. So just to give you the brief about Satsure, Satsure is a deep tech company that provides decision intelligence from space. That's a very important tagline, decision intelligence from space. When we started working in this domain, especially in the geospatial front, it was never about how you give out the data to the customer in terms of any map layers, vector data as such. But when we started discovering about the business process of a customer, identifying the pain points, and then massaging the information in a way where it could be directly ingestible in their decision-making framework. So just to give you the brief on that, I know you have been seeing this certain slides for many times in last 2-3 days. The reason I wanted to show you is that how the information has moved from last 2 decades, I would say. Starting from your IoT sensors to then UAV, and then now people are moving towards space in terms of getting the data at right time, at right location. So there's certain aspect of revolution that has happened in 3 fronts: spatial, spectral, and temporal, right? So when I say spatial, if you imagine the traditional satellite, which was starting from your MODIS to Landsat, then Sentinel came, which revolutionized how the commercial application could be scaled. And this is where, and then moving on, starting from tapping into some agriculture applications, now moving towards much more precision agriculture or monitoring certain infrastructure, that is where the need of high resolution payload came into picture. So the idea here is to showcase is that something that was military intelligence before, now it's accessible through various channels. Maybe that could be through the vendors, third-party vendors, or people are launching their own satellites nowadays, right? So, and top of that, revolution happened in 3 fronts. When I say 3 fronts, how the data that's getting captured, at what rate it is getting captured, how that is consumable by the customer, and what's the stack that's around it to enable that. So if you think about it now, what has changed in last 10 years, 10, 15 years? Count of satellite has gone up drastically, right? Then the cloud cost has came down from, let's say, 1 million USD for the storage and the compute to now it's almost equivalent to 0.019. And then a lot of research that is happening, the rate at which it's happening because of the cloud compute cost went down, so people can innovate at a faster rate. So how we do it at our end, right? So we at Satsure are not a geospatial company, neither we are a data science company nor a software company. We are working at the intersection of all these 3 domains. Reason to say that is when we talk about the data sourcing part, right? If you look at satellite data is not like your normal imagery altogether, coming from just RGB domain. But when you talk about satellite imagery, you have information in multiple bands at, let's say, a certain resolution, where you're churning out petabytes of data. Now, even before it gets consumed by any AI ML model, you need to do a lot of pre-processing on that front. And to do that at scale, It cannot be done on a, let's say, workstation where sitting at one location. And top of that, you need a lot of cloud compute to do that, right? So, on top of that, is it just the geospatial data that's going to solve the problem? This is where you need to integrate a lot of multiple data sets, starting from your weather, public APIs, for example, your government data, which is essential to validate your information, all that thing. Once that is done, you pass it on to your processing algorithm, for example, your AI ML. But we do not stop here. There's another layer there. And that layer is your visualization and contextualization, which we call about a last mile connect. As I told you, at Satsure, we follow a certain thumb rule. 80% standardization, 20% it will always be customization in terms of that last mile connect, how the information is getting utilized by the end customer. I'll walk you through some of the use cases that we're doing it at scale so that you better understand what I'm talking about when it comes to the last mile connect. But before that, the product suite that we have, right? We started from the solutioning side because I come from ISRO, worked there for 2 years, first batch of Indian Institute of Space Science and Technology, right? Starting from our BTech, we were engaged with space tech is so fascinating that we always wanted to work in this particular domain. And working in 2 years, went out outside India, did my MBA, came back, met my other founders, we are all the same batch. And then we thought, like, what is that one complex problem that we could actually solve from the geospatial data? And we could not think about any other problem other than agriculture, especially in India. The major problem for agriculture was the market linkage between the farmer and the supply chain, and then the financial inclusion issue, where your financial institutions are not well connected to the farmer. Access to credit was a bigger issue. That is where Satsure Sage comes into picture. It's a product suite where our applications are utilized by all the major banks right now to enable on underwriting, loan management, loan monitoring as such. But now we understood how geospatial data works, how it can be scaled. Now the same know-how was replicated when it comes to the infrastructure management. It's just that you're looking at not just agriculture feature, that you're looking at a man-made feature, right? But the thought process is same. Identify the business process, identify the pain points, align your data product around it. When we're doing all this solutioning part, we were highly relying on certain data set when it comes to agriculture application, which was good enough. For example, the data set, if I talk about Sentinel-1, Sentinel-2, Landsat, MODIS, right? Looking at average size of a farm here in India or any developed countries, right? Developing countries. But when it came to infrastructure monitoring project, the need of high resolution data came into picture. When I say high resolution, anything that is less than meter or so. And technically, everything was feasible. We all are engineers. We know how to build solution, build the tech stack. But customer was not able to cater to the data cost as such. It was literally 60 to 70% of that, right? And this is where and top of that, once we getting into any of the contract as such, we were not meeting our SLAs, service level agreement, the timely deliveriness of that, and the cost of acquisition, the lead time of getting the data was really high. That is where that Collider came into picture, where we thought, like, let's move to the upstream part. We know how the solutioning downstream works. We know how to solve customers' problem. Now let's connect it to the upstream part, where we want to launch our own payload in 2025. I'll talk about that payload later, but that's the whole gist here. And now we have like 4 product lines: Collider, Sparta, which runs as a data engine, which generates all the ARD data, and all those last mile connect happens through Satsure Sage and Satsure Skies. But what exactly are we trying to solve here? If you look at the current agriculture system or any input data that comes as in that you acquire as such, when we talk about the geospatial scale, it's really difficult to understand. If I just take an example of agriculture here, for example, there's no common repository of yield data. Your CCE data is unstructured in multi-language. There's no common repository there. There's no common, and it's even if you acquire them, you cannot trust them. right? And even to go on a ground to collect that data, it's really expensive. If you look at India, right, it's super big. And do that at scale for multiple crops, not possible. Accuracy is dubious there, as I told you. Reliability is a big issue. So we at Satsure are working at an intersection of solving the issues pertaining to agriculture, infrastructure, and climate action. So this is just a gist of what we do. And let me walk you through some of the solutions that we have built and how it is helping our customers as such. If I talk about agriculture, right? So Sparta is your data engine, where your all ARD, analytics ready data, is getting generated, starting from your sowing to harvesting and your intermediate data products. For example, your crop acreage, crop yield, crop performance in a season, that you're doing it at scale. But is that good enough for any business entity to make the decision, right? But we also understood that to enable this ecosystem, right, it's not just about what we provide as the analytics, but also you need to groom the ecosystem around it. When I say around it, meaning most of the enterprises do not have the know-how to churn the data at that rate, consume the information in a certain velocity, and the biggest impact factor would be the know-how of remote sensing, right? So this is where I thought, like, can we have a low cost API-based approach where anybody can come on the platform, build the application, because we have very few people in Satsure who can think about n number of solutions here. So can we enable the ecosystem to do that for us, right? And this is where Satsure Sparta helps us. And this is just a dashboard where you can visualize the data on a map front, also access that data through an API and ingest in any of the applications that you're trying to build. This is another interesting case. That was somewhere in 2019-20. It was not meant for any external release. It was meant for our internal release itself. Reason for that, we are working in Indian ecosystem here. There are two seasons. One is your Rabi, the other one is your Kharif. For Kharif, most of the satellite data we were acquiring, optical data, was cloudy. That means even not a single date was available. And we were not able to meet our service agreements because client trusts us to provide them the information at a timely manner. And this is where we had to think out of the box in terms of how you can leverage the potential of AI/ML to create those, I would say, value and reduce your operational cost. And this is where it's a classic example, which is the patented one, where we are doing a domain transfer from microwave domain to optical domain, where we are reconstructing each and every band, starting from R, G, B, NIR, and SWAR, which are important bands to monitor any vegetation in a satellite data. And when you look at the right side, that's another innovation which was catered from the internal lane, not from the external lane, which is something like a super resolution. Right now, we have a capability of monitoring and identifying correctly 25 major crops here in India, right? But looking at that, there are a lot of issues that we also face in terms of the mixed cropping, intercropping, small farms, etc., right? Here in India, the major problem is that our farmers are so well educated, they know how optimally they can utilize a farm that way. And to identify using a satellite data, especially with a 10-meter resolution, you cannot do it, right? And this is where the super rays comes into picture, where it helps us to bifurcate that thing properly and ingest that into any AI/ML model. Now, if I talk about the banking solution, right, what we are doing it for them. So we are doing that end-to-end monitoring for them in a season and a past season as well. It's the same thing, sowing, harvest, etc., and number of parameters that we are deriving. But the major challenge for any credit manager was that whom they should rely on. Was it on the CIBIL score, what individual has, which gives you the intent information, or probably can they have any alternate data along with the intent information so that they can make a wisely decision for a farmer so that he is not at a risk of not getting access to the credit here. And this is where we something came up with, which is called a Satsure, which provides you the capacity information of a farm by analyzing past 3 years of data, what type of crop it was, how much was the potential yield there, what sort of irrigation facility was there, how many times the cropping intensity was there in a year that way, which helps a banker to make those wisely decisions, to understand what could be the potential revenue opportunity for a farmer as well as his cash flow opportunities. That's for the underwriting, which is being used now. And then we're also helping, because that's how we started with any bank. We started our journey with ICICI Bank, understanding their process there. We started with 2 district monitoring here in India. Now it's scaled to 400 districts. We're doing it at a bi-weekly basis. The major pain point was they have a less operational workforce on the ground to do better collection, right? And because of that, the operational cost was going up. They were not able to cater it on a timely basis. Now we're providing that information just before the harvest, that these are the potential villages. This is where you need to go and collect for this type of crop, so that they can go and have a better negotiating power with the farmer and make them understand why they need to repay the loan, right? And then the farm monitoring, which people are already looking at. And then the same solution, if it's packaged in a different way, it can be used as a lead generation tool, portfolio monitoring at a village level, and a portfolio analysis at a farm level. Now, if I talk about infrastructure, that's an interesting case, because this was our first project that we did internally. It was simple. There was one input company, right? Their biggest pain point was that they had to make a lot of cold calls to identify where they can go and sell their materials, starting from your cement, anything which is related to that. And for them to do that, one cold call and converging one customer used to take at least 30 to 45 minutes, literally, right? Now think about it, they need to do it at a scale here. This was just a pilot that we did somewhere in Pune, in a Haveli region, right? Where we were able to provide a construction site where the constructions are happening at a 200-meter radius with a certain probability of what's happening there. And this is just one of the set of features. The reason I'm showing you this image is that human eye cannot see detail when you look at the satellite image. I know most of us would have done the digitization. That's the first exercise that we do by learning remote sensing GIS, right? You tend to miss out a lot of features there. But the capability of AI/ML tends to identify that. And if you look at this is where it shows you the heat map where the changes are happening between the 2 set of images by just looking at the textual information there. And this is just one of the value propositions that we provide to any of the EPC companies in terms of the solar panel, how the change is happening. This information is used for the project planning and project monitoring purpose. And just the time series information, how the changes has happened over the period of time. This is another example. This is one for the EPC company where they wanted to, first of all, their pain point was, again, I'm going back to the pain point, because any tech that you build has to solve customer problem. It has to create certain value, right? So for them, the cost of 1 kilometer survey was somewhere around 12,000 rupees, Indian rupees, right? And they wanted to identify from point A to point B, which is literally 1,000 square kilometer of area in matter of months, to do the survey and have an optimal route so that they can bid properly. The cost is less. There's a term, right? L0 and T0 kind of an approach where you need to have a minimal bid to win any of the tender. So that was one of the things. They came to us, right? Our first thing was, can we just use any remote sensing application with club with AI/ML algorithm to identify that, right? We did that. But we failed miserably. You know why? Because we never accounted for any business aspect in terms of where the angular tower should be, at what angle it should be, what should be the minimum span length as such, all those things. Once we understood that, we were able to cater that in our algorithm to give them the 95 to 96% of accurate results. 4% definitely, because any AI/ML algorithm will not be able to solve that for you. And this is just another example of, you might have seen by my colleagues would be presenting in terms of how the vegetation monitoring is done as such. But just to give you the business context, that was more in terms of identifying beforehand where they can lay out the power line. But now, once the power line has been laid, it's more in terms of operational management. How can you identify the risk around the existing power line, where the vegetation is happening, growing, and what's the risk it's posing on the existing power line itself. And this is one of the use cases that we are generally doing with a lot of insurance companies where they want to monitor the post and pre assessment if there's some natural event happening, starting from your floods to cyclones, that way. And this is one of the, that was more in terms of what we do for the customers and the clients, but we also do some of the studies. So I still remember the first case study that we did, and which our information was actually used by the Kerala government when the Kerala flood happened somewhere in 2017, right? For them, it was really challenging to identify which are the hotspots where the flooding extent was more and the damage was more. And we clubbed that information with the mobile tower data to identify the riskier zones where people are actually stuck. And it was used by the government officials to identify and go and rescue those people. So this is another example. It's a cyclone use case that we did to identify at scale where the damage has happened, and understand and quantify the extent of the damage. All these things, what I was showing was in terms of what we're doing. But now things also comes to the internal part. How we are also improving our operational efficiency to cater those customers. Coming to the Collidio, it's a subsidiary of Satsure, where we are realizing our hardware. It's a state-of-the-art hardware. The specification, so the need of this payload was because we were not able to meet our SLAs, right? But the one thing that we could have done is we could have leased out the capacity from external vendors. Simple, block deal, bulk deal, right? But that would also would not have, I would say, good enough for us, because if you look at large area analytics and if you look at the current payload structure, maximum what those people provide is 20 square kilometer, 25 square kilometer. Think about it. If I want to monitor, let's say, a Bangalore, right, which is roughly around 800 square kilometer, can I do it on a single timestamp? I cannot, right? And using that payload. And so this is where we thought, like, your SWAT has to be high so that you cover maximum area. Second, it has to have a certain resolution. It cannot go beyond that because the cost goes drastically up. And there are certain bands, RGB, NIR, SWIRE. But we were also focused on, we want red edge. The importance of the red edge in a payload, because it is essential part to monitor any biomass, understand the stress in a plant, right? So that is why the red edge was included, because now we're also moving towards the carbon side of the market, where we need to understand how the carbon sequestration is happening, how much is kind of getting affected, etc., right? So top of that, now if you look at my size of the image here, it's roughly around 65 by 65, roughly around 3,800 square kilometer area that's going to cover at 1 meter resolution. To downlink that much amount of information, it's not feasible. That is why we have AI processor at edge, right? Which will do most of your, let's say, the pre-processing part, which are good enough, can be done on a small shoebox kind of an hardware, which comprises of CPU, GPU, and VPU as well. In meeting our first milestone, right, for this, because it's a buzzword. Everybody wants to do edge analytics, edge analytics, edge analytics. But what exactly is the edge analytics? We never wanted to believe it blindly. We want to see it ourselves. Can we build those sort of algorithm? The first learning was that, can you use any satellite data as it is to train any of the models, right? No, you cannot, right? Now we had to wear our computer vision hat, where you need to think about what sort of augmentation can you do on a data set before you start even training. When I say augmentation, here in terms of how can you create different set of scenarios, different illumination condition, different weather patterns, right? Still you will be able to get that feature as such, because we never know what sort of scenarios that we may encounter in space while running this algorithm, right? That was the whole idea. And second, running it on a conventional cloud infra, it was roughly taking around 3 hours, 4 hours, but we had to optimize it. The optimization was not just on the deep learning, by the way, right? Yes, you can do pruning, quantization of the information, making sure you get certain accuracy. But the innovation that we had to do in terms of how you read and write the data. As in, can you use the standard libraries provided by any programming language? Or how can you create those machine logic by yourself? We had to think about it even before attempting this to run it on a hardware. In doing so, we became India's first company to run any sort of deep learning algorithm-based approach on a payload. We jointly did with Satlogic, which is an Australian-based company, right, which provides 1 meter information, and we had to partner for hardware with who was that? Spiral Blue, yeah. So, and in doing so, we were able to have a reduction in the volume by 99%. Our final information was in MBs, but initial your input data was roughly around 3 GB, 4 GB that way. And execution time from 3 hours was to 1.5 minutes. And these are some of the capabilities that we are building internally as a part of our pre-processing stack, starting from your automated geo-rectification, because my pointing accuracy of the payload would be roughly around 100 meter, right? I have to get it down to 1 pixel, which is 1 meter. That is why we had to internally do a lot of R&D there. And the other one would be image-to-image registration, which is also part of the Cygnus, because that's a when I say Cygnus, it was more in terms of how we do the reconstruction of the cloudy image using a microwave data, right? Before that, you also know that there's a lot of shift in the data of what you get in optical and the SAR domain, right? So we had to develop our inbuilt capability. How can you align the data, co-register the data before you pass it on to train the model? And in a nutshell, the point that I want to highlight here is that you can actually leverage the potential of data science, geospatial, and engineering together to create digital twins, to have non-OPEX based models where you can scale it globally, sitting here from one location. And doing so, if you're optimizing on certain factor, which when I say optimizing, you're affecting clients' bottom line, reducing it, and creating the top line efficiency for them. And if I put everything in a blue canvas, I would say, eliminate, raise, create, and reduce. When I talk about eliminate, see, satellite data is very unbiased data, right? But the potential comes is how you utilize it, how you create that value at the end of the day, right? So these are 4 elements to that. And in doing so, we are creating impact and working in a certain sector, agriculture, infrastructure, and climate action, keeping our sustainability goals in mind, right? And right now we are based out of Bangalore here, operating here, but we do have business unit in UK and US, and we are roughly around 150 employees. But what you see on the right side, right, that's a very interesting part, because there are few banks there, right? Those banks were first our customers, right? And you also know that getting money from bank is not that easy as an investor, because it's our own money, right? Unless they would have seen any value in how we are able to optimize their business process, what value we are creating for them, then they understood what potential that we have for a long term. And that is how ICICI Bank, Kotak, HDFC became our investors as such. Yeah, that's it. Thank you, guys. It was a pleasure explaining you everything here. Thank you.
Thanks for the wonderful lecture. And it's a lecture. In fact, it's a long way you have gone from advocating the satellite use. I just look into last year finances and other things. If you don't mind, where is the break even? Can you throw something on light on
Not
that?
right now. Not in the public. We
Yeah,
can
and
chat
another
later.
thing is regarding that precision agriculture. Other countries do that. This demand supply match. Some countries follow not to go for crops and anything on that line you are thinking?
Nothing as such, not especially in India, because there are a lot of dependency on the ground truth data that you collect first, and the type of information that satellite data provides, right? I would not say we're not going to get into, but that's not our forte right now and not the focus area. But probably down the line, when we look at integrating certain technology, when I say integrating, starting from your satellite technology to drone technology to IoT, then only you will be able to meet the precision agriculture aspect. Otherwise, just using satellite data, it cannot be done. But our major focus right now is how we can leverage the potential of satellite data.
Thank you.
Yeah, thanks for the nice talk. So you very rightly mentioned about the extreme customization that's required when the analytics goes to the user side, right? And there are many cases also which you showed from a company perspective, how repeatable the effort of this engineering, or any thoughts on that?
Yeah. See, I'm a firm believer that it cannot be orphan analytics. When I say orphan analytics, that means it cannot just solve one customer's problem. It has to be utilized multiple times, right? But when I said 80-20% rule, right? When I talked about 80% standardization, your base data product would be same, right? If I talk about farm agriculture data products, right? Sowing, harvesting, crop yield, etc., whatever that you could derive, right? But that last mile connect is how you're massaging that information in terms making it usable, right? One classic example would be the SAT score, where 30 parameters are going in it to create that SAT score. But all those parameters are same, which has been utilized by, let's say, a planning company or input company or a government agency, right? The way it is getting utilized, that's what it differentiates in terms of how they're going to use it at their end. So that last mile connect is not that big, but it's just that you have to spend some time to understand and how to align that. That's the biggest pain point, not to create those analytics. It's like you're creating a decision intelligence layer on top of it, which will have a lesser lead time as compared to understanding the business process and the pain point. So I would put it that way.
Thank you.
We have a question here.
The first question I want to understand is like barring that Ecology which is going to come up. So what is your current model of data collection? Like what insight I could get is you have some customers, they have some sites, they come to you, then you collect data, or maybe a lack of understanding. Can you throw insight on that?
When you say collect the data, can you elaborate on that?
Like you showed some sites, like you have say construction site, so you are collecting.
That was just a use case that we're solving currently. Okay. It's not about collecting the data. So
I will put it other way. What's the input data to you?
Input data is satellite data,
Okay.
right? Coming from multiple vendors, open source as well as commercial. Now, if I talk about open source, ESA is there, NASA is there, Sentinel-1, Sentinel-2, Landsat, MODIS, right? They have their own APIs, right? We have to create our own pre-processing stack before it gets consumable, right? So everything is built that way. Now, top of that, the algorithms are running.
But the resolutions level you are talking about, say 1 meter and so
10 meter for
10
agriculture,
meter.
yeah.
Okay. And second, maybe a bit technical question, like in Ecology, you are proposing AI-based processors on board.
Yep.
So, like it's a new system, right? So when we flow a new system, it has its own intricacies. So you believe like your AI-based onboard processor will work perfectly fine for a new system?
That is what we tried doing it with one of the milestones. So when I showed that result, right,
Yeah.
it was actually replicated in space.
No,
It's a Jetson device
okay.
which ran into space, right, and captured the information. Analytics were run, algorithms were run to derive the analytics, right? And the system that I'm talking about is a space-grade system,
Yeah.
right? So definitely there would be a backup, right? But we'll make sure that all the integration testing, everything is done beforehand, making sure that it's space qualified, and then transport it to wherever you want to.
Okay, thank you.
So you told about the crop yield estimation. So can I know that how you are estimating the crop yield from like ground truth or some data?
It's both actually.
Okay.
It's more like an active learning approach that we have taken. Where we built our models. It's a deep learning model, right? If I want to be blunt and honest, right, we're still at the phase of giving the potential yield. Potential is something like, if you look at the phenology curve as well, right, using a remote sensing data, right, what you get by looking at the information at a peak level, if you plot out the vegetation index, right. Now we are making a conscious effort to revise that to make it much more relatable to the actual yield. But now to do that, we are including a lot of other parameters, weather, soil information, that way. And now that is again getting collaborated with our customers, because it's not just the customer transactional relationship that we have with them, it's more like a collaborative one, where they're also providing the feedback to us in terms of what could be the potential yield, etc., where we are going wrong, how much is the deviation, so that it can make the iteration. That's one part. Now we have also created a partner ecosystem, because working in India, you need that partner ecosystem where you identify the vendors who can help you to do it at scale. So we are capturing the information from wherever we could, structuring it, putting that into a database where my data science and GS team are utilizing that to further improve the models, calibrate the models as such. Right now, as I told you, like we're highly relying on Sentinel-1, Sentinel-2 to do that. Because looking at a farm size here, half acre, probably you'll get 40 pixels to do that, so yes.
So I know there are a few more questions. In the interest of time, please take these questions offline.
Sure.
Mr. Rashmit will be there around to take your questions. Yeah, so with that, we'd like to end the plenary keynote. And I would like to invite Professor V. Sridhar from IIIT Bangalore, who is an expert in spectrum analysis. And I would like to ask him to present the memento to Mr. Rashmit for an insightful talk. Thank you, Sridhar. Yeah, thank you, Rashmit. Yeah. So now we move on to two plenary short talks from industry.
In the dynamic field of environmental technology and remote sensing, Mr. Alexander Weidauer has distinguished himself as a professional of significant impact. His journey in science and technology began at University Greifswald, where he earned a Master of Science in Physics, specializing in system theory. Currently, as the Chief Technical Officer of prestigious GALG Group, Mr. Weidauer leads the design and supervision of effective methodologies for all projects undertaken by the group's companies. His extensive experience in remote sensing and in environmental science is a driving force behind ongoing innovation and excellence in the field.
I want to talk a little bit about a small community which tries to build some devices for their own and give a small outline. We have built small devices, airborne devices for airplanes to monitor marine mammals and seabirds. And I want to sketch a little bit the journey, how we come to this and how we find solutions to bring this in. I come from an interdisciplinary context, working mostly for, working mostly for ecological and geodata mapping companies, make some sensor parts and tech parts inside of these companies, and yes, we do also modeling and so on. And in the last years, the usage of remote sensing systems for monitoring the eco-life on the sea is getting my focus. In the consumption of fossil resources, the availability We often see conflicts in use, distribution, as well. We have these negative effects on the climate. And at the moment, large efforts are undertaken to find sustainable forms of energy resources, and the offshore wind energy is one of these large possibilities to harvest energy from the nature. Unfortunately, these efforts are taking or using a lot of space in the sea. At the moment, we have about 8.4 gigawatt installed in the Baltic Seas. To compare it to a size or the capacity of a nuclear power plant, for example, Fukushima has the half of these energy amount in electrical terms. The installation of these systems is accompanied with a local industrialization process at the sea with very high space consumption. And the seas are not normal nature areas, so they are used by other stakeholders, and these leads to usage conflicts, and they has to be regulated. I have here a map drawn by the Federal Institute for Nature Conservation, which shows the EEZ of Germany. And as you see here, all the areas in the EEZ are either protection areas here or planned as wind farms, and only the waterways between these farms in planning are free of wind farms. So you can imagine how you have large installations there, and these installations has also a large impact on the ecosystem. This affects mostly fish stocks, the benthic species, stocks of marine mammals and seabirds. The buzzwords in the context of these conflicts are species distribution shift, habitat loss, neozoa emerge in these zones. We have biocontamination, and so on. And so a lot of monitoring programs are taking place in these areas. We have, for example, the scans programs 1, 2, 3. I don't know which number we have now. They are progressed every year. These monitoring programs are for the monitoring of marine mammals. And I want to sketch some problems of the things. For example, if you have a normal sandy ground on the sea, you have a biomass production of 250 grams per square meter a year. If you build in a windmill, this amount arises to 50 kilograms. So it's about 200 times more, I guess. And you put these nutrients into the system, and it's clear complete different species distributions occur, and the abundance changes rapidly. And it's not easy to decide, is this a good process or is it a bad process? Get we more fish or something like this? Sometimes you get biocontamination if you have layered marine systems where the upper layer is cut off from the lower layer, and you get fouling on the ground, for example. We have other problems for the habitat loss. So we have these wonderful birds, these long-tailed ducks, which breeding circumpolar about the Arctic here. And if the winter comes, all these birds go to a special place in the Baltic Sea over a flat ground where you have large mussel stocks with small mussels. And these are about 7 million birds. And they stay on these flat water grounds. Unfortunately, these grounds are also the founding grounds for windmills. And if you build in these windmills, you have a habitat loss. And to sketch this, I have here an example. We make some missions from 2014, 2017 to monitor the behavior of these birds, these auks, how the distribution of the birds change around the wind park. And as you see, these birds avoiding the things completely. They go away and you have avoiding distances about 2 or 6 kilometers around these parks. Imagine you have seen this map or this photo before, and you have parks everywhere, then the habitat loss is imminent. On the other hand, we have migrating birds like passerines. They always travel at night, and you have these beacons on the windmills, and these small birds have only fuel reserves for one start. And if they think they are at land and they stay at the mill, they die in great numbers. For the marine mammals, you can see they have problems if you construct the windmills. There you have these ramming devices which are underwater, very, very noisy. The marine mammals orient mostly by by sonar. Oh, sorry, by sonar, and often the air system is damaged and they lose their orientation, and then you have these stranding effects, these large stranding effects we often seen in the press. And all these aspects has to be investigated, and aerial missions are one tool in these things, in these monitoring. Monitoring was done years before, but by persons, manual. They use, normally these were called the Patenavia P68C, and here you see the ornithologists sitting in the back. They have dictaphones and flying at a height of 76 meters above the ground, and have some bubble windows, they call it, have stripes on the bubble windows so they can know in which sector they are, and then they start to collect birds and talk into the dictaphone and couple later on the time of the dictaphone with the GPS. This is a traditional method. You can imagine when you go with the airplane and in a very fast speed over the sea, how fast can you investigate these flocks, these number of birds? Are they 100, 1,000, 10 or something like this? Or especially if you go with a plane in these low altitudes, the animals starts to move, they flee, and it's difficult to count. And then another problem emerged, which is the wind parks itself. You see that we are operating normally at these height, and which is completely in the rotor zone, and you have these aerodynamics around the windmills, these swirls and so on, and it's very dangerous to fly in these parks with the airplanes. So what happened is in 2013, it was forbidden to make monitoring above the wind parks. And I want to sketch how we come to the idea for a very small community to build their own systems, their own monitoring systems, and yes, and how we stayed later on with a new one we built. And as you see, we have a long experimental phase from 2007 on, with some practical tests, and ground solution distance of 3 centimeters or 4 centimeters was reached. Mainly, the tests were taken out with large format cameras, and this resolution isn't good enough because we have birds, as you've seen with the auks, they are 20 centimeters long. So what you at least need are 10 pixels on length to identify the species. And then the things changed at 2011, 2012, mid-format cameras emerged, and we got these 2 centimeter resolution. Before this better definition was made, there's a proposal by the St. Andrews University by Mr. Buckland, and where was said, okay, we need at least 2 centimeter resolution. And yes. As you see here, we have these first camera which emerged and which was really cheap for this. And from now on, we got these 2 centimeter GSD, where the development goes very, very, very fast. Here you see such a wind park. So the setup from the normal operator flight was taken over and transformed into a remote sensing job. And all the parameters here, we need 2,000 square kilometers, 10% coverage, and so are the same as you know, or as shown you with the observer flight. And in 2020, we got a company who asked GALG to make a case study to build a new camera system on a small airplane, and we try to look what new cameras can do in the system, and we got better parameter, but a large amount of images to collect. In the design, we choose a diamond airplane DA42 with a tilted camera system provided by phase 1. Is stabilized by the gyros and has a classical photogeometric setup. Here you can see this is the design. It's a really small device, and it's classical airborne remote sensing with some tests, how is the footprint, how is the GSD, and so on, and like this. Maybe we can go deeper. Here I have some details what devices are used, but I skip over to this. So the main challenge of this was the real big amount of data, because we have to have overlapping images. This is due to the glare you have always on water. And for a 6-month period, we will collect about 500 terabytes of raw data, not of georeference data. And if you process the data, you will stay by 4 petabytes. So it's not an option for a small company to hold such an amount of data. So we decided to use a process images on the devices for analysis purposes only, such a dynamic approach. And at least if you have these 6 missions, you have also to calculate or to transform all the raw data into geodata in a very short time, so that you can stay and have always these six mission online for analysis, collecting and analysis. The rest is the common stuff, storage on LTO tapes and so on. On the other hand, we have the analysis of the system, so we have to need screening applications, identification applications, and we had also the idea that we can run the classification processes from artificial intelligence parallel to the working process for the analysis. No. Which leads to this setup. We have 3 stations, administrator workstation, where all the input is done. Then we have a large database and file server. We have a high-performance computer with a lot of CPUs and GPU cores. And then we have the backup and some separated network infrastructure where we can make the calculation and separate the user land from the rest. The problem by the calculation is that you have always this constant flow of incoming data, which are small at the beginning, if they come in, and go into the georeferencing calculation, and you need a lot of I/O performance, and then go back onto the file server, and getting small again. So this was completely trimmed to I/O rates and and pressed into this 4-day limit. Here we have the technological step up for the software. It's mostly open source with some small parts here from the phase 1 SDK to transform the raw data, which is in firmware data format, into TIFF. The rest one is written with open source software. At the end, for the analyzers, we have 2 applications. A screening application for fast screening or pre-screening the animals you find here, these are dolphins, I guess, into defined classes like bird fly, bird swing, and marine mammal, fishes, and yes, anthropogenic stuff, also man-made stuff and interferences. So this application is made to make fast screening. The other one is an identification application where you can bring all your attributes from the specialist into the data set you have marked. And yes, it's extensive. You have not much positive signals at least. And it's, yes. So it looks like this. I think I have not much time now. It looks like this. So you have a tiling set where you can go fast to the screens. You have here your sampled animals, and you go automatically through the tiling sets. You look 1 second at the images, mark your animals, and go on. So we can create mass screening for the about 9,000 images per camera you make in one survey. No. So and here I have some samples how it looks for some birds. Here you have the flying bird part, the swimming bird part, very small ones here. Then here marine mammals, and sometimes you have very fancy stuff like here swans in ice or in the man-made stuff. And then you have the identification part where you have to identify the animals and make some kind of QA, quality assessment, over the many ideas the identifiers have. So what to do next? We want to automate the process. So because 10,000 images plus to screen is a very tedious job, especially when the images in large area contain no positive sample. So the thing to have an AI to say, in these images is no bird on this tile. And this is one part. The other thing where we make some experiments is here that we have an AI which classifies the positive signals we want to have. The other thing in the future could be species identification, but it's very difficult. So what we have at the end is we have designed a remote sensing system for an airplane from scratch in about half of the year and integrated into the aircraft, which was also certificated. After 1 year, we have all the software running and all the computer systems installed. At the moment, we have about 170 missions flown with about 4 million images and 450 terabytes of images, raw images are collected. The screening identification from start to the end, or the identification process for one mission is about 1 or 1.5 months, depending on the investigation area. We have implemented remote screening successfully. We have colleagues in India who are screening the data which are hosted in Ireland. And the system is applicable for mass screening, which, yes, okay. No, so what can we do next is we could use these things beyond the normal sea monitoring stuff. Adding polygonal marker could bring more area of interest which we want to assess so that we can screen these large data stocks for other applications. We know that we are not a big team as we designed the thing, so the coast framework is overseeable, and I want to encourage everybody to do it on an airplane by themselves. And if you have questions how to do this, we are open for questions and how we can help you for support. And here I have at least one big image. This is a construction ship for wind turbines. These are the ramming devices here. Moment. No. And this means this is here the helipad, which is zoomed here. This is a net of the helipad, and the strips of the helipad have 2 centimeters resolution. Thank you.
We'd like to thank Mr. Alexander for this talk. We'll take questions after the next talk. I would like to request Professor Avik to present a memento to Mr. Alexander. Thank you. We now have a talk by Mr. Shubham Sharma of Galaxeye. So I would like to invite him to the stage.
Mr. Shubham Sharma is serving as the head of data at Galaxeye Space, Bangalore, India. His experience consists of serving as remote sensing and data scientist at Geospoc, Ola, and Hexagon Geosystems, and he has worked on utilization of Python for satellite image processing applications, specifically in radar remote sensing, and served as a research fellow on related projects with renowned space organizations such as ISRO. He has also presented at leading Python conferences such as PyCon India and has mentored at conferences such as SkyPy. Further, he has also served as technical reviewer of books on Python and has taken workshops related to Python programming for satellite image processing. He enjoys programming and strongly advocates outreach of open source technologies in geospatial sector.
Thanks for such a generous introduction. So yeah, I'd like to introduce myself and then I'll introduce what Galaxeye is. So basically, I'm serving as head of data at Galaxeye Space, and we're a small space tech startup who recently started 2 years back with an idea to generate data fusion, especially MSI and SAR. So next year by the Q3, we are planning to launch our own satellite, which will carry MSI plus SAR payloads on the same platform. And will be critically aiming at solving the data fusion problem. So my presentation is a little short and it will just focus on little bit aspects of the industry and what we are trying to solve. So, and this Galaxeye was started by 5 co-founders, Suyash Singh, Kishan Thakkar, Denil Chavda, and Rakshit and Pranit. So these all are 4 guys who were the part of the team Avishkar Hyperloop, and they came up with the idea of launching this satellite. And yeah, definitely we are solving some of the key problems that we face in the SAR multispectral data fusion. So I'll just go through what industry is working on and what spill little bit of point of thought where what we are solving at. So geospatial technologies are witnessing widespread commercial adoption nowadays. So main of the 3 of the key problems that are being utilizing remote sensing imagery are agro monitoring for banks, dark ship monitoring, carbon auditing for carbon traders. So if we come to agro monitoring for banks, a lot of banks, especially one of the use cases that I've worked previously in my companies was generating the indices through Sentinel-2 and correlating them with Sentinel-1 to provide insurers an idea how much insurance needs to be given to the farmers. So it's a growing field in which the industry is driven towards. A lot of insurance companies are working on fusing Sentinel-2, Sentinel-1 data to get the insights towards banks. The other thing is dark ship monitoring for marine insurance. This is a very interesting use case that people are working on, and where the SAR data provides a great insights into that. So one is detecting dark ships. So what happens is that the AIS data, automatic identification system for ships, gives pings of the ships regularly. When a ship moves from a particular source to destination port, it has to give the complete pathway to the maritime authority. So what these ships do, they switch off the AIS and they do some illegal smuggling and all that stuff. So in order to track them, SAR provides a great insight. So what we can do with the greater use of Sentinel data, we can get this, the total, we can correlate with the AIS data and find that which ship was actually going astray the path or must be involved in some of the activity. So that's one of the key use cases that's being worked upon. And another thing is ship wake detection. So ideally to detect whether it was a marine object, was exactly a ship or a buoy, maybe. So in order to identify that, we employ wake detection algorithms, such as where you get to know about what are the Kelvin wakes and the V wakes generating out of the ship, and to zero in on what is the bearing and what is the velocity of that ship. So it's a very important use case. And third is carbon auditing for carbon traders. So basically now, with the increasing carbon footprints, the companies are becoming more wary about what the carbon footprint they are leaving. So the MSI plus SAR both act as a leveraging point where they contribute a lot towards these use cases. So now if we see what's the trend going towards is, we see, if I talk about when I was a research fellow, I see that the usage of this data was strictly limited to most of the research organizations. Now what I see is with the opening of the data sets towards more and more towards the public, I see that a lot of development being happening over in this scenario. So basically more data is being made accessible, and data integration to using API stack is really great. So as we see more and more of OGC implementation standards coming up in the geospatial sector, if you see last week only there was a ISO TC 211 committee workshop which happened at Delhi, wherein they decided the geospatial standards for various kind of data, metadata. And I was also fortunate to attend the OGC workshop here as well. So it's becoming more and more standardized. So the way I see is that the geospatial ecosystem is developing at a very huge pace, and more inclusivity is happening in this scenario, in this sector. Then quick prototyping platforms are being developed. Like we see, one of the examples is EO browser being provided by ESA. So it's really a great platform where we can leverage different use cases and define different solutions. It's a great thing that a lot more traction is developing towards this. Now the problem again, which everyone is aware of, is that SAR and MSI both are we can say that they can act as complete. They complete each other. So MSI cannot give the cloud cover. Basically, it's inhibited by the cloud cover, wherein SAR gives us the cloud-resistant imagery. It can penetrate clouds. So basically, the fusion approaches of MSI plus SAR can give us good level of analytics, which we can utilize at various aspects. So whether it is in the case of oil spill monitoring, or is in the case of ship detection, or in the case of land use, land cover classification. But the problem again is it is limited by the spatial and temporal mismatch, which is the biggest problem here. So if you get the SAR data, it's very difficult to attain the optical data within the temporal time period in which you can analyze and develop any solution with that. So the need is easily interpretable data and highly available data at a very high repeat cycle, so that you can make your analysis more reliable. So the temporal baseline needs to be very less, and you need to have a very close spatially matched data in order to derive your insights. So SARS fills in the gap where optical fails. Now data fusion provides a way to reconstruct indices in cloud cover areas, especially agriculture. So we already have research proven where we use temporal transformer temporal spatial models, TTSMs, to generate the indices, to reconstruct the indices, especially NDVI in cloud-covered areas. So data fusion here plays a very important role, where the MSI is limited by cloud cover, we can use SAR to reconstruct those indices. So for again, the problem is closest matching spatiotemporal pairs need to be generated. So in order to tackle this problem, what Galaxeye is doing, we are mounting a camera which is giving us 7 bands, and along with that we are having a SAR payload which is X-band VV. So we will get the closest matching spatiotemporal pairs at the same time, through which you can develop your data fusion based models. So basically, once you have these pairs available with you, then another one aspect which you can work on is using generative AI to generate the training data in order to have both available at the same time and get your results with improved accuracies. So the thing is, generative AI, like it's being is being talked of recently. I think it's the future wherein we can generate a good level of training data, but more work needs to be done in this case. So data fusion, and one aspect is the availability of the data which Galaxeye is making. I think that will prove be a benchmark in the way ahead in developing the geospatial solutions. So one of our results that we got recently is the first drone SAR image that we have recently worked on. So we put a same drone we had a camera as well as the SAR payload on a single platform. We were able to get the images for SAR as well as the MSI. You see that there is a little bit of contrast issue here, but we are still working on our data and we are improving the quality of our data. Soon we'll be providing a good quality of data for both MSI and SAR. So yeah, that's something that we have recently delivered. It's still in the R&D phase. So basically, conclusively saying that the importance of getting temporally and spatially matched data, it will provide the best accuracy for the generative AI models. Like we see now, still generative AI is facing issues when we generate the geospatial data with it, because when it generates the data, there are very shadows are there. And second issues is that very relatively smooth edges come out when you have the initial results of the generative AI models. So in order to basically our fused optical and SAR data will be able to give better training data, provide a better training data in order for a generative AI model to have an increased accuracy of prediction. So customized generative AI models engineered to provide higher accuracy to geospatial data can be created through this fused MSI plus SAR data that Galaxeye is going to provide. So in short, we are working as a data provider as well as an analytics company, wherein we will be able to provide customized analytics on our data as well as on the open source data to the customers depending on their use cases. That's all. Thanks a lot. Any questions, please?
So you are putting both sensors on board.
Yes.
One is the optical sensor, one is the SAR sensor. So you are processing both the images on board?
Yes. So our plan is edge computing is already there at our site. We're still developing. The pipeline is in place and almost half complete.
Okay.
So edge processing will be happening. So if I talk in terms of drone, the pipeline is already in place and we are testing that on drone. Secondly, on satellite, our edge processing will be there.
So, but like in case of SAR processing, your image focusing is based on the match filtering operation,
Definitely.
where you can say the phase error can be introduced because of errors in velocity. So how you are going to tackle that?
So basically, I completely agree with the velocity errors. Our operations are designed in that phase in which that will be compensated. Further, we are using back projection for generating our data.
That will be very time consuming operation. How you will execute that on board?
We are currently optimizing that.
Okay.
Sir, can you just emphasize on how you are actually thinking of just estimating this carbon auditing part? using MSI and
I have
SAR?
not specifically said that we'll be aiming carbon auditing. I'm saying that carbon auditing is one of the important applications in which the industry is focusing on. So our main goal is not carbon auditing. You already have dual pole studies done in which you can estimate carbon footprints through, I think, LOS2 data.
Okay, sir.
I think sir has a question. Why, sir?
Sorry, I thought that is someone. You are keeping two sensors, and SAR always look one side. This look vertically. You want to see same area, and you will tilt optical sensor.
A compromise is being made between the two, sir. I completely agree that it's neither looking and it's off looking. It's the look angle, the tilt is there. But our operations are taking care of this geometry. So it's still being in progress, wherein we are getting. So I'd like to answer it very vaguely that the geometry is such like that there will be a sufficient overlap between the two pairs that we get, the two images that we get.
Okay, what is the height you can fly and how much?
Currently, our drone is demonstrated at 100-meter flight, at 100-meter altitude. X-band, VV pole.
Sir, thank you so much, because fusion is right now a very crucial topic which is coming up. So I have a question that generally when people perform any optical and SAR fusion, so they generally stack the information, like they will take the bands from the optical and SAR, the backscatter intensities. So is generative AI going to utilize any other fusion technique within itself to perform the feature?
Currently, I'll say that no sufficient research is available right now because the work is still going on. If you talk about pix-to-pix, big GAN, these models, stable diffusion. So the research available is giving sufficient but not accurate results when it comes to SAR to EO image translation, when it comes to SAR to MSI image translation. So I'll say that it's still a work in progress. I cannot comment on that whether it will be high accuracy because it's going at a very faster pace. But what I can guarantee is that, yeah, a better level of data can be made available for the generative AI to train on.
Okay. So because like when we think about the Indian climatic conditions, so like you use this optical and SAR to solve the problem of this gap filling, right? So can we also perform any kind of fusion, or do you aim to perform any kind of fusion using multi-frequency SAR in that way? Because sometimes we see that the C-band performs really well for solving problems of classification when the crops are in its vegetative stage. But as the crop grows, they grow to the higher stages, so the accuracy reduces. But L-band, which has a higher penetration, so it kind of shows better performance in the later stage of the crop. So any kind of multi-frequency SAR fusion can be achieved by this generative AI in that aspect.
Hopefully, I think I'm not the right person to comment on that because, yeah, I mean, it totally depends on the use case that you are completely aiming at. So if you say, when I work on a particular use case, I first identify very clearly what data will be able to help find my solution. Then I go to the resolution at what I'll be aiming at. Then finally, I'll aim at whether I have to use fusion or not. So I think it's completely use case specific that you are aiming.
There's one more question.
You are archiving raw data or not for this mission on board? It is any plan for raw data, actually acquired sensor data?
For drone, we only get the raw data.
For you are telling about spaceborne image.
Spaceborne raw data will not be made available public to the user. The raw data, level 0 data you are talking about?
Yes.
For the SAR?
Yes.
Yeah. So currently we don't have any plans to make L0 public to the users. L1 and L2 definitely will be disseminated to the users.
Sir, if any time you need reprocessing, so you can able to do all those things?
So as of now, as per as policies, we have the L0 data available for internal R&D use for making our own data better. So in case of research, if it happens, we might, under different policy mechanism, we might have it distributed with the experts to evaluate the quality of our data.
Yeah, so thank you so much, Mr. Shubham. I would now request Dr. Ujjwal Verma, Professor Ujjwal Verma of Manipal Institute of Technology, Bangalore, to present the momentum. Yeah. Thank you. Thank you, both of you. Now we'll take some questions for Mr. Alexander. Sorry, we have to wait till the end for that. Any questions for, yeah.
Hi, Alex. It was a great presentation, very insightful, and sort of the kind of technology that goes into behind the scenes is fascinating. I had a question about a two-part question. One question is about the transferability of the same pipeline for other species that you mentioned,
Yes.
like beyond marine, what has been demonstrated now. So have you done any experiments to see sort of the kind of work it will take to adjust the parameters for that to work, or like the kind of data set that it requires for it to work in that way? And that's the second part of the question is whether you have also looked at sort of ASICs, like application-specific integrated circuits and things like that for your data pipeline, because it looks like a very sophisticated system. So to speed in the process, have you looked at any ASIC pipelines as well?
Yeah, thank you for the question. I think for the other animals, we are focused on really on offshore, and making photos on offshore is a tedious job because you get so poor light back from the water. And then you have always this split between very, very large animals. If you have a whale and you compare it with, let's say, a long-tailed duck or a scooter, yeah, so we have a small black dot, and then you have this big animal. So I think, yes, it depends on how you define your flight task. And then you have to change all the things, you know, from photogrammetry, so you have to change the lenses and so on. And it depends on the task you want to aim. So if you want to monitor elephants, which is, for example, is a request made from South Africa, there is an approach to monitor the, how you say, that the elephants don't get pregnant, and they give them pills and something like this, and they have to identify the individuals, and you do it by the ears of the animals, because you can see which animal has eaten such a pill or something like this, which is feed, and then you can see is the complete herd or some could it be pregnant or not? And yes, and then you have changed the system. Then you have a more oblique system, and it's such a task you can do. And for the second question, I don't catch the the question exactly. Sorry.
Sorry, my bad. I was just curious to know if you've explored sort of hardware pipelines for your image processing and sort of that part of the
Yeah.
like, because I saw mostly software pipelines for your image, for your image analysis. But given the scale of your operation, even for a single project, I was curious to see if you have explored sort of hardware acceleration for for pipelines specific that you have developed.
Yes, we had a cooperation with a company who delivers us the computers. And so we sit a long time with them together and ask for I/O rates and which devices we have to use to store intermediate results and so on, and design the pipeline with them together. And yes, at least it was a cooperation with the industry. I can say it was Thomas Krenergy, is a German company, which sells Linux-based service systems, and they give us a lot of advices how to stick the pieces all together and where to place the things.
Yeah, thank you, Mr. Alexander. We'll now proceed for lunch, but a few announcements before that. So our afternoon sessions are quite packed. So we will have the research track running in R101 to R105 sans this room. Here we will be having industry track. And after that we will be proceeding for the cultural event, which is in the third floor. It's called Amantran. So you can use the lift lobby to go in there. Then after that we will proceed to Hotel Radha Regent for banquet dinner. There will be shuttles running to go to the Radha Regent. It is a pleasant 20-minute walk if you would choose to walk. but you can take the shuttles as well. So please be patient. We'll have to run multiple shuttles because it's only a 50-seater bus, but then we will make it there in multiple trips. Okay, so thank you so much. Please proceed to lunch. We'll see you after the lunch. Thank you.